Hi everyone, greetings for the day. This is Priyanka, working as assistant professor for the Department of CSM, and today we are going to discuss about the K nearest neighbor algorithm, which is going to play the prominent role when you are working on a sample data sets or simple data sets, usually for the student projects. So, coming first, we are going to look at the definition of this. What does the key nearest neighbor algorithm is going to look like? So, this is a simple supervised learning method will be used for both classification and regression. So, first of all, when we are trying to consider one kind of data set and it has to be trained in a simple supervised machine learning kind of thing, in this case, nearest neighbor algorithm can be applied for both classifying the data and making regression tasks on the state. So how does it work is nothing but we are going to find the k nearest data points to a data point and predicting its class for classification or the value for regression. So we are going to now see what this k factor is going to mean and how we are going to classify the data and how we are going to attain the value for regression. Right. Uh, Next, so coming to the understanding, so basically, when we are trying to analyze one data set, and upon that data set, we have to know what classification is going to look like and what regression is going to look like, right? So here, So here in machine learning, actually classification is going to aim like assigning the input data to the predefined categories or classes. So we are going to attain some kind of data sets, and for this predefined data sets, we are going to uh, just we are going to predict like whether that particular data point is belonging to that data set or then that data cluster or not. Yes or no, that's it. And coming to this regression, it is going to predict the values. Like, for example, if you wanted to predict some no, random value, we are going to apply some formula on it, and it is going to predict. So, for example, it is going to predict the price or temperature here. And coming into deep, we wanted to see like what we are going to learn in this video lecture. So we are going to look at why do we need this KNN and what is this KNN? How do we choose the K factor? When do we use this KNN? How does KNN algorithm work? And we are going to make a small case study on by considering one kind of data set, sample data set here, right? So coming to this next slide. So by now we all be familiar with what machine learning models are going to look like and what is the main task of this machine learning algorithm. So let me give an example. Machine learning algorithm usually what it does is going to do is nothing but when we are going to give an input value. Let me take give you like example of weather prediction and something. Let me take that example. In this predictor, I have trained this machine learning model, and I'm just going to give a date like 6 May 2025. What are the temperatures are going to be like here, and it is going to predict the output for me. Like that might be a normally in this some for a 35 to 45 degrees range or something else it is going to give. This is what a particular machine learning model work is going to work like. Right. So nothing but we are going to make some predictions on the data while it is going to learn from its past experiences. This is what we know about machine learning model. And coming to our kind of KNN model, what we are going to do is nothing but, for example, I'm trying to build up a intelligent model where I'm going to give a picture input, and it has to predict for me whether that particular picture belong to the class of cats or it is going to belong to the class of dogs, right? So here what I'm trying to tell is nothing but I already stated that in the first slide. I've told that it is kind of supervised learning. Supervised learning is something where we are going to give the detail about the data we are storing in the dataset or database. Right. So for cats, I'm going to give the qualities or the attributes like sharp claws, uses to climb, smaller length of ears, meows and purrs. doesn't love to play around. So these are the some kind of attributes I'm going to train along with the data image of cat. And coming to dog, I'm going to provide the data image of dog. In that dog, I'm going to give the characteristics like dull claws, bigger length of ears, barks, and loves to run around. So these are the some kind of detail I've given for the data of dog picture, right? So how does this going to work or help me in predicting the K factor? We are going to discuss now, right? So here on a graph of some xy axis have taken and sharpness of claws and length of ears. So in the previous slide, we have given that we are going to consider this clause attribute here. Uh, and based upon this clause and based upon the length of ears, any two kind of attributes I'm going to map, and I'm going to take the values on x and y axis. So as we stated that cats are going to have sharp claws and dogs are going to have dull claws. Based on this and the length of ears of cats and dogs, we are going to plot it on a XY graph. So as the sharpness increases, cats are going to come into that cluster, and sharpness decreases, dogs are going to come into that cluster, right? Length of ears of dog should be higher, and sharpness of claws is going to be higher. So in this manner, what we are going to do is nothing but we are going to differentiate and we are going to plot the data points on a XY axis. So this is the first and preliminary step we are going to do while we are trying to train the algorithm. Means we are giving some kind of knowledge to this particular data set where it will be able to differentiate different kinds of data sets or points based on the attributes we have attached to them. So this is the first step we are supposed to do when we are supposed to implement some kind of KNN algorithm on a data set, right? So after that, what we are going to do is nothing but example. I'm trying to give a new picture into this data set. So whatever the points we have already plotted are existing kind of things, existing kind of data points. And in this existing kind of data points, I'm trying to give some new kind of picture, and I have to just justify or I have to predict to which cluster is this particular new picture is belonging to the cluster of cats, or is this particular a new figure or new picture is belonging to the cluster of dogs. So this is what my task is going to be now. So for this, what we are trying to do is nothing but, as we know that KNN is going to any machine learning, not only KNN, any machine learning algorithm or a model is going to take a input. It is going to make some process on the output, and then we are going to give the predicted output. This is the basic kind of thing we have discussed before starting KNN. So here the KNN is based on feature similarity. We can do classification using KNN classifier. So this is what our programmer is going to think, because I'm having a special algorithm called KNN where I can take the input of data set and I can predict it and I'll give the output, predicted output for this. So what how a programmer should think, that has to be, that theory has to be mapped to the this kind of implementation, right? So for this, what we are trying to do is nothing but we are supposed to analyze what KNN algorithm is going to work like. So as we already discussed, KNN is one of the simplest supervised machine learning algorithm which is used for classifying the data points based on how neighbors are classified. So here we are going to just classify. So here, if we see the plotting, if we remember the plotting, have cluster. We have classified the cluster of cats and we have classified the cluster of dogs as well. So here the new data point has arrived in the middle of the graph, and this has to check each and every data point, and we have to just tell S it is going to belong to cats, or S this is going to belong to docs. This is what we are going to do now. So here, what KNN is going to do is nothing but KNN is going to store all the data available cases and classifies new cases based on a similarity measure. So this is what the point we are going to make a note of. So what KNN is going to do? It is going to grasp the data which is existing inside its data set, and it is going to make some similarity measures for every data point existing on the graph. So that is going to be my first step in the implementation of algorithm, right? So next, so here in this graph, if you see, I've considered two kinds of things, like two kinds of data sets are there. One is yellow colored wine and one is red wine. And new kind of data point has entered into my data set. And the constraints I've taken is on the y-axis, I'm considering sulfur dioxide level and chloride level. So this is the another data set rather than the data set we have considered now, right? So on this data set, we are going to make an analysis, and we are supposed to predict which cluster this particular new entry data point is going to belong to. So here KNN is going to come into picture, and we are going to analyze, and we are going to make some similarity measure for it, and predict which kind of data point this new data point is going to belong to. And next. So here, K in KNN is a parameter that refers to the number of nearest neighbors to include in the majority voting process, right? So here, what we are trying to do is nothing but based on the types of attributes we have given on X and Y axis, we are going to calculate the K value for this. Means we are going to calculate the K factor for the new data point. How we are going to calculate data K factor, we are going to look at. So how we are going to choose this K factor? How can we justify that this K factor equals to something else, some numeric? How? Like KNN algorithm is based on feature similarity. Feature similarity is something like what kind of attributes features it is going, that particular new data point we are going to analyze first, and then choosing the right K value is a process called parameter tuning, and it's important for better accuracy. So for finding the K value, we are going to consider the feature similarity, and then we are going to find the K value by process called parameter tuning. And it is, of course, it is important for assessing the K value for better accuracy. So at K equals to 3, we can classify as how we are going to see now, right? So KNN algorithm is, as we know, KNN is going to be based on feature similarity. In this process, we are going to choose the better value for the K, where we are going to calculate. So for example, this is the new data point available, and these are the existing data points, right? So here we are going to form the clusters like this. In this, I'm going to consider this data point, and from this data point, I'm going to calculate the similarity measure for every point. So for example, from this new variable to this, from this to this, and this to this, I'm going to make it was a one cluster, right? So here, as in this cluster, nearest to this, only 3 points is present. I'm going to consider that my K value is 3. And I'm going to extend my cluster or far away. And I'm going to consider how many kinds of things are present on the whole in the, again, upper cluster. So in this upper cluster, 7 data points are present. So this is the way we are going to calculate. And after that, how do we choose the K factor? So my question is, in this previous slide, we are going to have both red squares and purple triangles. So my challenge is how I'm going to choose, what data points I'm going to choose, which data points I have to consider for choosing the K factor. So this is what my challenge is now. The class of unknown data point was squared at K equals to 3, but changed at K equal to 7. So which K should we choose? So here, my challenge is, in this particular analysis, what I've done, the clustering, whatever I form, K value is two different K values I've got. Okay, one is belonging to square and one is belonging to triangle. For square, we are going to getting K equals to 3, and for other category, we are getting K equal to 7. So my challenge is now, which K factor I'm supposed to choose now. For this, what I'm trying to do is nothing but I'm going to apply a small formula here. To choose the value of K, we are supposed to form the square root of n, where n is the total number of data points. And next, the odd value of K is selected to avoid the confusion between two classes of data. And what if I'm getting two values as odd? This here, my challenge is going to be addressed. Right. So next, what we are supposed to do is nothing but we may get a question like on which kind of data points or on which kind of data sets this particular KNN algorithm can be used. This is my next analysis I have to make before I apply KNN algorithm on a data set. So when we can use KNN when the data is completely labeled. Bina labeled data and I'm not considering any labeled data, it is difficult for me to attain some attributes and make some analysis on it. So for sure, whatever the data set we are going to consider should be a labeled data. And we can't apply KNN algorithm on huge or complex data sets because KNN is a lazy learner. Lazy learner is nothing but it is going to consider every data set, every single data point belonging to my cluster and calculating the similarity measure for each and every data point which is present nearer to the newest neighbor. It may take some kind of time. So that is why we are going to term it as a lazy learner and it is does not learn a discriminative function from the training set. So KNN can't be applicable on the data set which is complex, but it can be applicable on a smaller data set like which is going to have minimum kind of data. And KNN cannot be applied on the data which is noisy. What do you mean by noisy data? So for example, in this particular table, which is visible here, we are going to have three columns, weight, height, and class. In weight, of course, the numericals has to be given. Everything is right here. In height, numericals has to be given. Bina alphabets and everything. Only numericals are present here. And in the class, we are going to tell whether that particular weight comes considering weight and height, am I underweight or overweight or normal. So these are only the three attributes I'm supposed to present in the class column. But in this data set, rather than this underweight, overweight, and normal, I'm having three other variables which is not matching my requirements. So what I'm trying to do is nothing but I'm going to term this particular table or a data set as a noisy data. So this kind of data can't be considered to process through KNN algorithm. So coming to the point, KNN can be applied only on a table data set, only on a simple data set, and it couldn't be applied when the data set is large or filled with noise. So next, how does KNN work? How we are going to see what is the actual working of this KNN. Consider a data set which is having two variables, height in centimeters and weight in kg. And each point is classified as normal or underweight. So this is what my data set is, a data set analysis, and this is what my data set is going to look like. So here, that things like weight, height, and class are going to my labels. And whatever the values in the rows I'm going to give here, that will be my row values. For weight, I'm 51, 60, 167, and it is underweight class. So this is my sample data set where I'm going to apply the KNN algorithm first of all. After that, on the basis of given data, we have to classify the below set as normal or underweight. So these are the existing data points. In this existing data points, I'm going to consider two more values like 57 kg and 170 centimeter. And I'm going to predict what kind of class it is going to belong, like underweight or normal. Right. So assume that we don't know how to calculate BMI. And here my problem is my machine learning algorithm doesn't know how the BMI calculator calculations, and it has to predict using this KNN. This is what my challenge now. So how I'm going to address is nothing but to find the nearest neighbors, we will calculate Euclidean distance. As we know, Euclidean distance is something where we are going to have different data plots on the data set, and it is going to calculate the distance between two different points. But what is the Euclidean distance and how it is going to look like? So according to Euclidean distance formula, the distance between two points in the plane with coordinates x and y and A and B is given by distance d or squares of x minus a whole square plus y minus b whole square. So if we consider the simple data points like this, the distance is we are going to calculate the distance in this way. So we are going to calculate it. And after that, we are going to calculate the distance between the existing data points and the newly entered data points, and we are going to calculate D1, D2, D3, everything, and we are going to attain some values here. Right. Similarly, we are going to take every point which is present beside or nearer to this, and we are going to calculate this value for that. Hence, we have calculated Euclidean distance of a noun data point from all the data points shown. We are going to choose based on the data set which is already trained. We are going to give a value x1, comma y1 will be 57, comma 170, whose class we have to classify. So based on the data trained, I'm going to just push into that cluster now. Right. Now, let us calculate the nearest neighbor at k3, k equal to 3. So I'm going to consider every point. I'm going to consider only 3 points. That will be my k factor. And I'm going to consider what is the Euclidean distance for every data set, data point present here. And I'm going to analyze which data point the existing data set is going to belong. Right. So here, so majority neighbors are pointing towards normal. Right. So whatever the value we have got for the new data point, we have made some analysis on it, calculating the Euclidean distance for both x and y values. That is nothing but height and weight values. And this particular points are pointing to a class called normal. So we are going to decide, like we are going to, that particular new data point is belonging to the class called normal. Now let us make a recap of KNN. When a positive integer k is specified along with a new sample. So this is the what the major factor or major kind of thing we have to analyze before implementing the KNN algorithm. We select the k entries in our database which are closest to the new sample. So when we are trying to select the k entries in our database, we are going to choose the points which are closer to that existing data point. That is the second recap of KNN. And the third point we have to remember is we find the most common classification of these entries. When we apply some calculations on it, we are going to find the most classification on these entries. This is the classification we give to the new sample. So this is where we are going to give the classification to that new sample. This is where our KNN algorithm is going to work like. And here I'm going to just analyze this predicting of diabetes. So I'm going to consider the diabetes data set where it is going to consider consist of 768 people who were or not who were and or not diagnosed with diabetes. So that the data set is going to consider both diabetic or non-diabetic students. So this particular data set, on this particular data set, we are going to make some analysis and predict. We are going to do some prediction on it. So this is how KNN is going to work like. And implementation, let us go with the next video. Meanwhile, let me show how to gather the data set from open sources. So this is what we are going to look. So here I'm going to Google. Just a second. So in this Google, I just wanted to see the data set of diabetes. So as we know, usually whatever the training we are going to give for a machine learning algorithm, that should be in a comma separated value. So that's what I'm trying to search here. And here I'm going to go for this Kaggle website. In this Kaggle website, what I'm trying to do is nothing but here I'm going to find the data set, and here we are going to download it. So before that we have to register for it, and then we can have access for this open data sets, right? So it can be downloadable now. Simply we are going to click on download, and we have downloaded the diabetes.csv. So here, as we discussed in the example, we already told that it has to be in the form of the data set, which is to be tabular, and it has to be in the form of you can say labeled data. So this is my sample data set, and in the next video we are going to see and we are going to code how to predict for the new data point which appears in this data set. Thank you. Thank you so much.